On the next slide, we see an example of a variable that we could count as a numerical variable. So another question on that California Pizza Kitchen survey was, please rate your overall experience. Respondents could indicate 1 for poor, 2 for fair, all the way through 5 for excellent. We have a frequency distribution of this variable, and you'll see the frequency distribution is pretty much the same as the previous one, except there are 2 additional columns indicating cumulative counts. It's very important for you to understand how to use these cumulative counts. These cumulative type columns are going to be with us for the rest of the course, so you got to get very good with them. So what are they? Well, they just keep a running total of the counts. Let's start with this first row. You'll see that there were 27 people who indicated that their experience was poor, which represents about 0.2% of the population. The cumulative columns are the same. Let's go to the next row. There were 178 people who indicated their experience was fair. If you add 178 to 27, you'll get 205. That is what the cumulative column tells you. It's very important that you understand what that cumulative column is telling you. Likewise, if you add up these percents, so 0.2 plus 1.1 is 1.3, that is what the cumulative percent is telling us. Now, one way that is often used to summarize such questions on 5-point scales or 7-point scales is called the top 2 box score. So the top 2 box score is simply the percentage of people who check the top 2 boxes. So it's a way of simplifying this table. So there are 2 ways to get the top 2 box from this frequency distribution. One is we could just add 44.6 to 43.0, which gives us 87.6%. So 87.6% check very good or excellent. So that is the top 2 box score. Another way to do that is to use the cumulative percent column. So notice that 100% of the people check excellent or less. To get the top 2 box score, what we could do is take those who check the bottom 3 boxes, so 12.4% of all people select poor, fair, or good. And if we subtract that from excellent, that's another way to get the top 2 box score. So if we take 100% minus 12.4%, let's go do that in Excel. So if we take 100% minus, 12.4%, you get 87.6%, and that's exactly what we got when we added up these 2 values. So I know this seems very trivial right now, but these basic skills of subtracting, a number from 100 versus adding them up are going to stick with us for the rest of the course, and you need to be very good at them. So that's about it for the frequency distribution. The next thing that we might want to do is to visualize this. Now, we visualize numerical variables with a histogram instead of a bar chart. So here is a histogram of this frequency distribution. You'll notice a few things about this histogram. So first off, the spaces between the bars have been removed. Again, that's a visual cue indicating that this is a continuum as opposed to discrete categories. Now, all the bars have the same width. They all have a width of 1. So in this case, the areas, the lengths, and the positions of the ends of the bar are all proportional to the counts and the percents. You want to get in the habit of only looking at areas for histograms. So come chapter 7, when we get to random variables, the only thing we're going to be interpreting is areas. So the areas are what you want to interpret. Now, when you look at the areas, you're going to see a whole lot of mass out here at 4 and 5, indicating that the vast majority of people check 4 and 5. Not a whole lot of people check 1s. Very few people check 2s. Not many check 3s. All right, so this histogram is a very concise way to summarize the distribution of this experience variable. Let's go on to the next slide. The next slide gives us a much more complicated frequency distribution. So this is a variable from a large national survey. It happens to be the crime survey conducted by the U.S. government. This survey asked people, what is your age in years? And you'll see that values range from 14 all the way up through the oldest person in this survey is 96. So this is a fairly complicated frequency distribution because of all the values that it takes. Now, if you look on the next page, I give you a detailed description of each of those columns. You can read that on your own. But let's go down to this last part, which asks us to do 5 questions. So let's do these questions. So what percentage of people are 40 or younger? How many people are 65 or older? And so forth. So these questions illustrate the basic things that we will want to do with frequency distributions. If you can answer these 5 questions, then you are in, you know everything you need to know about frequency distribution. So you might want to just pause the video and see if you can answer them on your own. Now I will work them for you. So why don't you try them on your own first, but let's now do them together. All right, so I'm going to go over to Excel. It's probably easier for me to write in Excel than it is to write on this pad that I have. So I'm going to say let A be the age of a respondent. Now, the first question asks, what percentage of people are 40 or younger? We're going to be using a special notation coming up. We're going to say, what is the probability or the percent of people where age is less than or equal to 40? Now, it's not essential that you grasp it, but you probably want to start understanding this notation now. So how are we going to do this? The answer is we're going to use the cumulative column. So the cumulative column will make our life very easy. Here's this cumulative percent column. And if we come down to 40, remember this just keeps a running total. So the answer is 42.1%. So let's go take notes in Excel. So the answer is 0.421, or you can write 42.1. So that is exactly the same thing as 0.421. So you could also say 4.21%. I don't care. The next question says, how many people are 65 or older? So number of people who are 65 or older. To answer this, we want to use the cumulative frequency column. So let's go to the bottom, and you will see that there are in total 18,775 people who responded to this survey. Now, to get the number of people who are 65 or older, the hard way would be to add up all these individual counts, but you don't want to do that because that's too much work. So instead, we're going to note that the number of people who are 65 or older is just going to be 18,775 minus the number of people who are 64 or younger, which is 15,794. So let's go over to Excel and type that in. So 18,775 minus 15,794. And so the answer is 2,981. Now the next question in the course packet was, what percentage of people are 65 or older? So we'll write this as the probability or the percent of people where age is greater than or equal to 65. All right, well, we're going to do something very similar to what we did in the previous part. And we're going to use the cumulative frequency column. So notice that 84.1% of all people are age 64 or younger. Therefore, if we take 100% minus that, we'll get the percentage of people who are 65 or older. This is a really important skill to have. So what we're going to do is say that this is the same thing as 1 minus the probability that age is less than or equal to 64. So let's go do that. So it's going to be 1 minus 0.841. So that's 15.9%. So we can say that 15.9 or 16% of the people in this survey are aged 65 or older. So that's a very important skill to have. We're going to use it throughout the rest of the course. The next question asks, what percentage of people are between the ages of 40 and 60? Well, this is the next type of skill that we need to have. So what percentage of people are between the ages of 40 and 60? That's the way we're going to write this. Now, we want to be able to use this cumulative column to evaluate this probability. Remember, the cumulative column answers less than questions. So one thing that the table will tell us is the percentage of people who are 60 or younger. So this probability is indicated from the cumulative percent. But we have a problem because we've counted too many people with that percent. The people that we don't want are those who are 39 or younger. We remember the question is asking what percent are between 40 and 60. Well, we're going to take those who are less than 60 and subtract off the percent who are less than or equal to 39. So let's go get those percents from the table. So somewhere up here is the percent who are less than 60. So 79.1% of all people are less than 60. Now if we go to the 39 row, you're going to see that 39.2% are less than 39. So if I go back to Excel, I'll stick that in this row. We're going to take 0.791 minus 0.392, and so the answer is about 40%, 0.399. So 39.9% of all people are between the ages of 40 and 60. Let's do another one since these are kind of tricky. So the last part asks, what percentage of people are between the ages of 25 and 40? So we're going to do exactly the same trick. That cumulative percent column will answer the question, for example, what percentage of people are 40 or younger? But this counts too many people. We don't want those who are 24 or younger, so we're going to subtract off those who are less than or equal to 24. So let's go get those 2% from the table. So the chance that you're 40 or younger from the third question was 42%, 42.1%. The chance that you are 24 or younger is 5.4%. So I'm going to go subtract those two probabilities. So 0.421 less 0.054 is equal to 36.7%. So you should practice these skills because you're going to use them forever. You can also do problem 1 in the worksheet for this week. That's on page 61, I believe, of the course packet. That'll give you some additional practice on reading a frequency distribution.